Okay, so let's go over the quiz. Okay, so here's your quiz. Okay, and what it says is 70% of all college students own or have access to a car. It must be true because Google said so. So again, don't 100% trust, but I actually did look it up, so I did have a source for this one. The Tahoe Transportation District suspects that this percent differs for Lake Tahoe Community College students and will be performing a study to find out. Okay, so what I'm going to do is I think it's easier if I actually copy and paste this into the answer sheet area, so I don't have to go back, forward, and backwards and stuff because the calculator is kind of in the way. And then we can start answering the question. So first, state the null and alternative hypotheses for the corresponding hypothesis test. All right, so the first thing you want to ask is, what is the survey question? Always how you start all of these problems. What is the survey question? See the top chat box, you can say it. Yeah. Do you have or have access to a car? And the answer is yes or no. So because it's yes or no, when we have our H naught, what letter do we use? What letter handles, P handles the yes, no question. So H naught is that P is equal to, and what number do I put in? Yeah, 0.7, because it's 70% is what the status quo is, and we want to find out if LTCC is different. So now H1, and now we want to say, what is the alternative hypothesis? What is a key word here that helps us decide in terms of, I'm going to write P, and then I'm going to write 0.7. And what is the key word that helps us decide what inequality put in? Yeah, that word differs. That word differs does not mean lower, does not mean higher, okay? It means not equal to. You see, there is no less than for a keyword, but there is a differs. There is no greater than or more than, but there's a differs. And differs translates to not equal to. And I'm going to be formal. And by the way, if you write NOTEQAL, that's fine. But since I'm teaching this, I probably should do it right. And that is relationship. There it is. Not equal to sign. Any questions on part A? Okay. And by the way, for a project, then I want to see real symbols because then you have time and resources and you can ask questions and all that. Quizzes are different. Quizzes, if you write NOTEQAL, that's fine. Okay, so now we're supposed to state the ramifications of a type 1 and type 2 error. Okay, so note, by the way, the Tahoe Transportation District is going to do the study. So that's important to note. That helps us with the type 1 and type 2 error. So let's start with the type 1 error. So if there's a type 1 error, what are the ramifications? So first thing, what happens? What does it mean for it to be a type 1 error in terms of this situation? Any thoughts? I don't see y'all jumping in. Okay, so type 1 error means that you accept H1, right? Reject H, not accept H1. So we're going to accept that no, it's not 70% of all Lake Tahoe Community College students. Okay, it's a different number. It's a different percent for LTCC students. Okay, on the other hand, it really is, even though we thought it wasn't. And that's what a type 1 error is that you think H1 is true, but H1 is not true, H0 is true. So now let's think about it in terms of what the Tahoe Transportation District might do in this case. If they think it differs then they're probably going to change. They're probably going to either decrease or increase, depending on how it differs, the amount of opportunities for transportation, right? If it's on the high side, they're going to say, well, students don't really need transportation. They have a car, okay, in terms of getting buses to and from where they need to go. Let's have hope, and eventually we'll open up and we can say to and from Lake Tahoe Community College. But it's so hard to come up with questions nowadays. So I don't want to all be depressing. So I tried to make it more realistic of not today, but maybe 6 months from now. On the other hand, if they think the other way, if they think that students don't have, LTCC students don't have enough access, okay? Yeah, exactly. Then what they might want to do is they're going to say, well, students don't have access, and if they don't have access, we're going to do even more to try and get transportation to them. Maybe instead of every half hour, I think is what it is, maybe 20 minutes, maybe every 4 minutes, we'll send a bus to Lake Tahoe Community College. And then what would happen in that case is that you'd have a bunch of empty buses because all the students are driving to the college anyway and don't need transportation. So it could go either side, but the point is that, and I'm going to write TTD because that's the abbreviation that everyone uses for Tahoe Transportation District. TTT will change or adjust the number of buses offered. We want S in buses, I guess so. Okay, the number of buses offered, thinking that it's not 70%. And either there will be too many buses, okay, and a bunch of empty buses, or too few. Any questions on that? Okay, that's a type 1 error. Now let's go to type 2. Okay, so type 2 error, what does that mean? Okay, and by the way, LTCC students get a free ride. You may not know this, so does everyone else. Right now, buses are free in Tahoe. So they've gone to that, and I think it has to do with coronavirus. They didn't want to handle money. It was too dangerous. So just let you know, whether you're a student or not, you're all students, so you get one anyway. But even if you're not a student, you get a free bus ride. I figured I'd let you know that. Okay, so type 2 error. Type 2 error, what does that mean? And the idea is kind of the opposite. So what does that mean? Any ideas on what type 2 error is? Start with TTD because that's who is interested. So it's kind of the opposite. It means that they were not able to accept H1. Okay, yeah. So it is different from 70%, but they weren't able to make that conclusion. So TTD was not able to conclude that the percent of students, LTCC students, with access to a car differs from 70% when it actually does. Okay, now this is not the ramifications. The next sentence will be the ramifications, but I think it helps for you to see this sentence too. So now it's kind of the opposite. So TTT is going to say, well, no problem, 70%, just like we're doing. Okay, does that make sense? Okay, because I don't see any difference in 70%, and those will go as it is, when in fact it is different. Okay, so no adjustments will be made. On the number of buses. But either there are fewer than 70%, in which case, so that means that we're not going to make adjustments, but students really need it. Students will be left out. Or more than 70%. So that means that we, students basically all have cars or mostly have cars, and they're not going to take the buses, and the buses will be empty. Any questions at all on a type 1, type 2 error? Okay, now let's go on and talk about part, I think it's in here. There we go. Part C. Based on part B, decide on the level of significance. Explain how you decide on a level. All right, is one worse than the other? What do you think? Or are they basically just as bad? What do y'all think? Yeah, they're just as bad. Okay, so since the repercussions are basically just as bad, remember what I told you, if they're just as bad, what should we use for the level of significance? What number? Yeah, 0.05. Use 0.05 for the level of significance. Any questions on that? Okay, now part D. Now I'm going to talk about the data. Suppose that of the 300 students surveyed, 228 of them own or have access to a car. Find the test statistic and the p-value. 228 of 300. And note that we have a 0.7 as our null hypothesis. Okay, because now I have to go to the calculator. What number should I use to get the calculator? Okay, 15. Yeah, hypothesis test for a proportion. So P, remember the P stands for proportion. That's why it's proportion, and this is a hypothesis test. It's not a confidence interval. So it's a hypothesis for a proportion. And we just plug in. N was 300. The X was 228. And our P naught was 0.7. Was it 218? Let me double check. No, 228. I don't think I changed anything. I just copied and pasted. So yeah, it's 228. Really? Is it 218 on your quiz? I'm confused. I don't even know how I could do that. I didn't change anything. All right, well, I'll go for the 218 if you guys want. Whatever said on your quiz is what you should do. So I'll put in 218. Okay. I'm confused. That shouldn't happen in a computer system. It shouldn't give me a different number than you guys. So that's okay. I believe you. So let's go to 218. And that was over here. Which of these three, less than, greater than, or not equal to? Okay, I believe you. I believe you. What I don't understand is how it happened, but I do believe you. So is it less than, greater than, or not equal to? Yeah, this is a not equal. Okay, because that was, again, if you look at our H not, it's all there. If you look at H1, it had a not equal to sign. So not equal to, and I hit calculate. The Z is almost exactly 1, which is interesting. Okay. Again, I just randomly chose some numbers. I didn't make that on purpose. And then the p-value is 0.3135. So, test statistic was Z is equal to basically 1, and the p-value was equal to 0.31334. So look again, 3135. It was 49, so 5. Any questions on using the calculator? Okay, so now part E. Use the language discussed in Tuesday's webinar to state your conclusion. Okay, so what are the first few words? It's always a good idea to know the first few words on a test because they'll get you started. What are the first 2 words for any hypothesis test conclusion? First 2 words. Simple words. No, not fancy statistics words. Data, not quite. What I wrote 2 days ago, I know it's been 48 hours, but still makes it hard. There is. Do you remember that? And now the next word is one of 2 things, but in this case, our p-value is large. Okay. Notice, by the way, our p-value is large. I don't even have to give you a level of significance. I mean, you don't even have to get a level of significance because 0.3135 is giant. Okay, there is no level of significance that would be bigger than that anyway. So if the p-value is large, what's the next word? It's always going to be these same words. There is, you do know, but I like statistically. And then insignificant evidence to conclude. And then we state H1. Basically, we're saying we can't state H1, and that's why we state H1. Insignificant means you can't do it. So H1, again, let's look at it, was P not equal to 0.7. So now take P, and what is P? 2 words. They both start with P. Two words that both start with P. Do you remember? Okay, population proportion. Okay, Pop Pro is just fine. But I'm going to be more official, I guess. Population proportion of LTCC students, because that's who we're looking at, who have access to a car. I think if you own a car, you have access, so I'll just keep it as have access, is not equal to 70% or 0.7. Any questions on that? There are other ways of saying it, but you must reference the population. So there must be a word in your conclusion that references the population. That's true of all hypothesis tests. When you're doing the conclusion, it's also true of all confidence intervals. So that's really important, is that we're talking about the population. We're not talking about the sample. We're talking about all students at LTCC. Okay, that includes all of you all and everyone else at LTCC. Any questions on that? Okay, and then finally, interpret the p-value in the context of the study. And that was a little bit longer, but it always has the same form. And maybe I'm going to write down, again, this is not going to be the interpretation, but it's kind of a nice, it's like the form. The form is if H naught is true, Okay, again, you're not going to write this for the answer, but this is how all answers look, and then you make adjustments. And if another study was conducted, then there would be a whatever chance that the new study would be as extreme as what we found. By the way, not good enough to say that, but this is the general way of doing it. Now let's turn this into our particular study. Okay, so if H naught is true, so go down, look at H naught. H naught is P is 0.7. So that means if 70% of all LTCC students have access to a car. Okay, so that was if H naught is true. And if we surveyed another, how many did they survey? They surveyed in here 300. It's in there somewhere. There it is, 300 students. So if we surveyed another 300 students, then there would be and now the p-value is 0.3135 or 31% chance that, and now we have to say that the new study was extreme as what we found. But what we found is of those 300, 218 owned or had access to a car. So extreme means on either side, because it's a two-tail test, not a one-tail test, that either at least 218 of the 300 students would have access to a car, or again, the 218 is the high side. Notice, actually, it's always a good idea to check. 218 out of 300 is over 70%, because 210 over 300 is 70%, because 3 times 7 is 21. That's how I got that, by the way. Okay, so this is actually the high side, the 218. 70%, again, is 210. So the low side will be 212, or at most 212 of the 300 students would have access to a car. Okay, any questions? This is always hard for people. Any questions on how I got the 212? You want to see the arithmetic that I did? Because this could be hard for some. Okay, so what I did is the first thing I said was 70% of 300 is equal to 0.7 times 300, which is equal to 210. Are you okay with that arithmetic right there? 70, not 75. Okay, so that's the first thing I did. Then notice that 218 is greater than 210. So that's why the at least 218, that's the high side. Then note that 218 is not just greater than 210, but 8 greater than 210. Is that clear? Okay, so then if the high side is 8 greater, the low side is 8 less. Then the low side will be 210. Wait, sorry, not 212. See, that was a mistake. You should be worried about 202. That's a typo. 210 minus 8, which is equal to 202. So that's how I got that's how the 202, it should be 202, not 212. So it's 202. You could do percents also. This particular one, I was able to do it in my head with numbers because it was like good, easy numbers. Percents are a little harder to do in your head because if you ask me what percent 218 is of 300, that one's not as easy in my head. Yeah, if you use your calculator, that's fine. You could do percents, and then you would say whatever that is. The 218 might be 70. Let's see, 8, 72.33, 72.67%. I think sounds right, ish. Okay, so 72.67%, and then you'd say, well, that's 2.67% higher. So you go lower than that, and that would be 67.3%. Yeah. And then you could do it that way too. It's the same. Whether you're doing percents or counts, it's the same. Okay. And notice it's of the 300. It's not a population. This is of the sample when you're talking about the p-value. Any questions at all on this example? On this quiz? Okay. All right. What I want to do now is I think I'm going to move on and basically do another hypothesis test. But what haven't we done yet? What kind of hypothesis test haven't we done? Yeah, mean. So I want to do a hypothesis test for mean, and I got it set up while you guys were taking your quiz. Okay, so I have a question for you. All right, I was able to look up very quickly that the average age for US Congress is 58. Okay. Okay, and by the way, I almost ran for Congress, actually. The Democratic Party was going to fund my entire campaign. They really were pushing, and I did a lot of research, and I found out I would lose. So that happens. I'd have no chance. Just my county and my philosophy are not the same. So we're the reddest state in all, reddest county in all of, or reddest district of all of California. So I wasn't going to win. I'm not that red. I'm a teacher. Yeah, I'm not moving either. So I like Tahoe too much. Okay, so this meant something to me because, you know, this was a while ago. This was about 10 years ago. Okay, so here's the question I have. Is the average age for California state Congress? Okay, and that's Senate and Congress and Senate. Different. From the US Congress. What do you think? You think it's different? Okay, maybe, maybe not, right? How do you find out? Yeah, we sample. Okay, so what I did, I only had so much time. There was no way I was going to get every congressperson's age in the 20 minutes, not even a full 20 minutes that I had to do it. But I got a group. So I got a group, and what I did is I went online, and I just got the list of Congress people in California, and I don't know if you call it randomly selected, but I grabbed a bunch of them, and here's why it wasn't so random. I wanted to at least grab ours, McClintock. Okay. And then I grabbed all of our state Congress, the people that actually sit in state. And then, do you recognize any of these people? Besides McClintock, there's one other you should recognize. Do you guys vote? Okay, if you're not, I understand if you're not a citizen, you can't vote, but okay. Bob, I don't even know who Bob is. Maybe Bob's a big shot. That could be. The one you're supposed to recognize is Frank Bigelow. He's ours. He's our district representative. Okay, so that's the one you're supposed to know. You could know others too. I just grabbed a bunch of random people. And I grabbed Frank Bigelow because he's ours. And I found their ages. Wikipedia is great. You can get age of anyone basically on Wikipedia. I haven't checked mine if it knows my age, but it might. But it definitely knows our senators and Congress people. Okay, and there is the list I was able to get. Well, you were, and one more, sorry. Let's do this. I think there we go. There's our list. Okay, this was the list I was able to get while you were taking a quiz. Okay, I didn't have time to do them all. Is this a large enough sample to not have to make any assumptions? What do you think? Okay, the answer is no, and how come? Okay, what do you need to have to be a large enough sample to not make assumptions on the sample size, on the distribution? Yeah, we need to be greater than 30, and we're less than 31. Okay, so first thing is we must assume that we have a normal distribution. Otherwise, we can't do anything. Is it a normal distribution? I doubt it, but it's as good as I can do. So when you only have 20 minutes to do a study, don't publish it. Just let you know that. Okay, so this is just for this class. But when you do a study, then you do a real study. So we must assume that the distribution is normal. The distribution of ages is normal. Okay, and remember that word assume, is that a good word to have to do or not a good word? Hint is look at the first three letters. Yeah, it's a bad word. Okay, it's probably wrong. Okay, I have no clue whether it's a normal distribution or not. Okay, I do know how to make tests on it though, which is beyond this class. So remember those elementary stats, and if you decide to take an advanced statistics class, then you'll do something called Kolmogorov's test for normality, and you'll learn how to do tests to see if it is normal or not. But we're not doing that in this class, so right now you just have to know to state we must assume, since our sample size, which is 2, 4, 6, 8, 10, 12, 13. Since 13 is less than 31. Okay, any questions on that so far? Okay, the next thing I want to do is we want to do a hypothesis test. What is H naught? Which technically I should have written before any of this happened, any of the research was done. I actually had my H naught kind of written up here. Right, there's my H naught in words, but we should have our H naught before you ever collect your data. You should always get H naught. So what is H naught in this case? Yeah, so first thing, it's not P anymore, it's mu. And I'm gonna make it look pretty. I'm actually gonna put a true mu in there. Mu equals 58, because that's the age of Congress people in the US Congress. And we're looking at California. So mu means the population mean of California Congress people. Okay, so that means that our representatives in and out of California that live, that are from California or live in California. Any questions on that? Okay, we need H1. All right, and let's take a look. What's the inequality going to be? Based on the words of the hypothesis. Is it going to be less than, is it going to be greater than, or is it going to be not equal to? That's the question. And there's a key word in there that we're looking at right now. Yeah, it's not equal to, and the key word is different. So the word different is a not equal to word. Again, these aren't supposed to be trick questions. This is just understanding the English and turning into the symbols. So H naught is still going to be a mu. And then it's a not equal to. I think it's there. Yep. Not equal to 58. Any questions? Any questions at all on stating the null and alternative hypotheses? All right, how about type 1 and type 2 errors? If there's a type 1 error, then is anyone going to die or anything because you did a type 1 error? No, no. You're going to publish a paper, right? Maybe in a magazine or something that says, you know, California is not the same as the rest of the country. And you're going to have an article and you're going to talk about some research you did and you're wrong, but there's really no horrible things that are going to happen. Is that clear? So I'm going to just say repercussions of a type 1 error are that you published an article that stated were different, and we're wrong about it, and that is not true. So we might be we might have a loss of reputation, right? People might know us for someone who publishes things that aren't true. That's a bad thing, but it's not like no one's going to die or anything. Any questions on the repercussions of a type 1 error? What are the repercussions of a type 2 error? Okay. What's that mean? Any thoughts? So that means that the ages are different, but we weren't able to decide, we're able to say that. We didn't have evidence to show they're different. If we don't have evidence to say we're different, then we're not going to publish the article. Do you see that? You don't publish an article saying, I don't know anything. So what's going to happen is we will lose the opportunity to publish the article about what we thought, when in fact, what we thought was correct. And we probably won't move forward. Let's say we won't get promoted by the news agency because they don't even know who we are because we never even published an article. Does that make sense? So what do you think? One worse than the other, about the same in terms of, you know, terror? Yeah, these are about the same. So if they're the same, remember what you use. What's the level of significance you use? You're all supposed to know this. Yeah, 0.05, a 5% level of significance. Any questions at all on that? Okay, again, I actually, you know, I thought about all this stuff before I collected the data, and that's important. You're supposed to do that. But I wanted to show you that the data could be collected, and it wasn't that hard to collect the data. So then you're supposed to go and collect the data. Okay, that's the process. The order is very important. Is you never analyze the data and then decide on your hypotheses. Okay, there is a case, and it's not statistics, where the data is looked at, and then a decision is made after looking at the data before you even talk about any hypotheses. Anyone know what that is? It's the up and coming field right now in the world. And it has a starting salary of around $300,000 if you guys want to go into it. It's very hard though. I've been offered 400,000 and I said no. Because it's something I know how to do. Anyone know? See y'all jumping in? Artificial intelligence. That's what artificial intelligence is. What it does is it collects all the data and then looks at it, finds patterns, and says this is what's going on. Whereas statistics makes a hypothesis, then collects the data, and then verifies or does not verify the hypothesis. And this is a statistics class, not an artificial intelligence class. So the order is important at which we do this. You must first have your hypothesis, decide on your level of significance, then go collect your data and analyze it. Okay. Any questions at all on that? Okay. And by the way, artificial intelligence takes a huge amount of mathematics, statistics, and computer programming. That's what it's all about. If you're wondering what it is, it's not some spooky robot. It's literally a bunch of programmers who know stats and math. I like teaching. That's why I didn't do it. So it's not about money. Money is not life, at least not to me. Okay. Anyhow, now let's do the data. And what I'm going to do, because I want to, this will lead us into the project, is I want to do the spreadsheet. And to save you time, I typed in the numbers. Also, while you guys were taking the test or the quiz. And there's our data. So there's a spreadsheet. Notice we're on the one var stats because we only have one variable here. And that is the age is the variable. And what we have, notice the mean is 54.15384645, right? By the way, is that less than 58? You better all know that. Is that, or sorry, is that different from 58? Is that different than 58? This is an easy question. It's not a trick question. Okay, I don't think I even need to ask it. Okay, but I just want to let you know that this is different from 58. So if it's different from 58, does that mean we get to reject the null hypothesis because it's not 58? And we want to find out if it differs from 58. What do you think? Because that's the more important question. Is that all we need to reject the null hypothesis? Is that we looked at the sample mean, it was different than 58. There it is. Is that okay? Yeah, we can't do that. And the reason is this is a sample. It's not the population. If we had the full population and it was different than 58, then you're done. But the population would have been way too hard for me to collect all the ages. I had to do them one at a time. I didn't have time. So this is different than 58. Okay, but it doesn't help that it's different because we need more information. Any questions on that? Okay, then we can start talking about more information. And the more information is we can now say, well, let's let this be a not equal to. Let's let mu naught be 58. There's our t statistic. Remember, use a t statistic because there's a sample. We have no idea what the population standard deviation is. So that means the t is that adjustment factor. And then more importantly, the p-value is about 0.3. Okay, to 2 decimal places, 0.30. Any questions at all on that? Okay, so the p-value, let's go in here. Notice the p-value. In fact, let me write down the test statistic, because you can be often asked about the test statistic. The test statistic was t equal about 1.09. On the homework, by the way, carry more decimals. On quizzes and tests, I don't really care. I just want to see work shown. That's the important thing. But computers aren't able to understand that, yeah, you just didn't do enough decimals. But I am. Okay, and the p-value was equal to 0.30. Any questions on that? All right, so what does that tell us? So what does it tell us if the p-value is 0.3? And you can give me the short answer first, and then we'll do the long answer. Yeah, it's too big, so we fail to reject. So that means there is statistically insignificant evidence. To conclude that the population mean, remember that word has population. Population has to be there. I take off points if you don't have the word population. Population mean age of California, all right, CA, Congress people, differs from US, Congress people. Doesn't like my grammar, but I'm good with my grammar. Any questions at all on the conclusion? This is the punchline, so you don't want to mess this one up. Okay, notice the two key letters right here, in. That means that we don't have significant evidence. So we're not able to make a decision. That's all this says. It's a very fancy way of saying we did a lot of work and we know nothing. That's all this says. Any questions on that? Okay. All right, type 1 or type 2 error, which is the one that we should be concerned about now, which is the possibility? Which is possible, type 1 or type 2 error? Only one of those is possible. Yeah, now type 2 error is the only possibility because we failed to reject. And type 2 error means you failed to reject when you were actually right. Okay, when it was different. Okay, so I'm not going to write this out, but the type 2 error is the only one that's still of concern. Whereas before we looked at the data, where is it? Before we even popped it in the spreadsheet, type 1 and type 2 errors are both of concern. But once you look at the data, that changes because now you have new information. Any questions on that? Okay, the next thing to say is, what about the standard error? Let me pop that in. The standard error was 3.5, about 3.5. Let me just write that out. This is the next important statistic I want to make sure we all understand. What does that mean? We talked about it in chapter 7. Don't you hate that when I say, you're supposed to remember what happened 2 weeks ago? But we did talk about this in chapter 7. What does it mean to say the standard error is 3.5? Can you remember? Okay, so that's a standard deviation of the sampling distribution. Now that's fancy words. So let me put it in nice, easier words so it gives you some meaning. So we can say is that on average, such studies of Congress age will differ from the true mean. I mean, like true population mean by 3.5 years. Okay, so now we're talking about our sample mean. So note that our sample mean was 54 years old. So what this says is that, yeah, we got 54, except that 54 is probably not right. It's probably off by 3.5 or so. Maybe a little higher, maybe a little lower, but 3.5 is kind of a good guess from what it might be off by, plus or minus. Do you see that? A little different than a confidence interval. Okay. So that's just a note. Here's another question. Based on this, should we do a new study with a larger sample size? What do you think? And the key is, look at that p-value. So you think so, think not? Okay. So here, this one's a maybe. P-value is 0.3. It's not like it's 0.95 or something. We're not that close to our 0.05, but we're not that far, especially considering the fact that our sample size was so low. Our sample size is 13. When you have a sample size of 13, you're usually not going to get any good information. So note that the sample size is 13. Actually, was 13. So 0.3 is not that high. So which means it's still a little hopeful that we might be right. Whereas if you got 0.98, it's hopeless. Do you see that? But with a low sample size, you're almost never going to get really low p-values. Therefore, the only thing we can do is increase the sample size And the whole point of increasing the sample size is to decrease the standard error. So remember, if you increase the sample size, the standard error is sigma over root n. That means the denominator gets bigger. The denominator gets bigger, the number gets smaller. And if the standard error gets smaller, then you're going to be more likely to the true population mean, likely to be close to the true population mean. Any questions on this idea? This is the new idea, and it's what most people have trouble with. So I wanted to spend some time on it. Any questions? Okay, let me tell you what's next. Okay, unless there's any questions, I'll go over any of this example. Okay, I want you to try now. So here's what we're gonna do. I'm gonna stop sharing now. And what I want you to do, I'll even put it in the chat box. Although I think when I send you into rooms and you don't get the chat box anymore, but at least you can copy and paste if you want. So I want you in your group to do something similar. So what I want you to do is I want you to think about something you might be interested in looking at, something that you could very quickly get online, and I'll let you know ages of famous people, you can find anything about them. Okay, and what you need, or almost anything, not anything, but almost anything. So politicians work, actors work, sports people work. You can get their ages. That's never a problem. Wikipedia, I just type in Google, and what I want you to do is I want you to come up with a hypothesis. Right, you can do two groups. Yeah, you can do two groups. I want you to come up, so it'll be like pairs, basically. Okay. I want you to come up with a hypothesis that you can collect data on. Does that make sense? So my hypothesis was, I think that the age of our California Congress people differs from 58 years old. Does that make sense? And it should be something that you grab data from the internet. Okay, there's a lot of data on the internet. So it doesn't, so what you can't do, for example, is say, how many units are LTCC students taken? Because you can't find that on the internet. You can find an average number of units, but you can't find individual people's units. Does that make sense? So you have to be able to grab data. And a data set of 10, even though you have to do that horrible assumption, make an ass out of you and me, as they say. And but again, I don't want you to spend all your time collecting the data. And you can share the work on collecting the data if you can't find it all in one list. And then I want you to do a full hypothesis test. So do everything I did. You got it? And I'll be around to help you. I know I'll be in one of the rooms to help you, and I'll probably spend some time in the other room, and we can help you out. And then I want you to do, again, all the different things that I just talked about, which is basically what you had to do in the quiz. So this chapter has one question, right? The question is, A, what is your hypothesis? Hypotheses. B, what's type 1 and type 2 error? C, what should your level of significance be? D, what does your data say? What's the p-value? What's the test statistic? Right? The next one would be, based on the p-value, state your conclusion. Okay. If you have time, you can include explanation of the p-value, explanation of the level of significance, and then you should talk about the standard error. Okay. So every problem, it's a lot of pieces, but every problem is exactly the same pieces. So what I'm going to do is I'm going to pop you into groups, 2 rooms. I'm going to make it manual. Let's see if I can do this. I haven't done a manual one. I want to assign. Here we go. Okay, I just want to let you know, no matter how you feel, everybody is pretty confused right now. Okay. And it should open up and you should be able to join the group, and I'll be popping in too to answer questions. But make sure you join your group. I think I'm going to pause the recording. I hope I can remember to make the recording happen again. Okay, thanks a lot. So you guys had a chance to come up with your hypothesis and get a p-value and then interpret it, hopefully. I think we're going to start with the Michael and Erez group. So what I'm going to do is I'm going to mute myself so that you guys can present your findings. So what you should do is basically, you could do it orally if you want. You share your desktop if you want, but you can also do it orally and talk about, and I know, Michael, you're having trouble with Mike. If you want to pop in the chat box what you know, any things that you want to add to, that's great too. And just spend a few minutes talking about what you did, what your p-value was, kind of each of the steps. And let's see how you do.
Okay. So yeah, like Michael said, his mic is broken. So I will do it and then he can add whatever. So for our project, we're gonna, the null hypothesis is that the age of the average NHL player is 27 years old. So H sub 0 was mu equals 27. And then our hypothesis was H sub 1 mu does not equal 27. And then our next step was finding the errors. So type 1 was pretty similar to the example that Larry brought up earlier, which was just that we published an article saying the NHL age is different when it actually wasn't. And then the type 2 error was that we would lose the opportunity to publish the article about our hypothesis, even though we were actually right, even though we were led that it wasn't from our sample. And then using these two errors, we decided that the level of significance should be 0.05 because the ramifications are pretty similar. And then we went ahead and collected our data. And we had a biased sample actually because we looked up top 10 NHL players. So that's just an interesting aspect of our study. And we came up with 23, 24, 23, 26, 28, 34, 31, 32, 24, and 22. We used the calculator and we got a T of negative 0.2208 and a p-value of 0.8302. And then using that p-value, we could make an easy conclusion. And so we said there was, I guess, strong statistically insignificant evidence to conclude that the population mean of age of NHL players differs from 27. And then we had time to interpret the p-value. So we said if the population mean NHL players age is 27, and if another 10 players are surveyed, then there would be a 83% chance that the sample mean age is between or is less than 26.7 or more than 27.3. And I think that's all we got.
So do you think it would be a good idea to do another study based on what you got so that you can get a smaller standard error with a larger sample size?
Well, I think that's a hard thing to decide because the sample size is so small, but the p-value is really large. So I probably wouldn't do it again.
All right. Your p-value is so big, it's pretty hopeless at that point.
Yeah.
You know, you can still keep hope, but it's just, lost faith, I guess.
Right.
It's probably not going to happen, so it's not worth your time. Does that make sense?
Yep.
When you got such a big p-value. Okay, whereas a 0.3, that's not that big, but the 0.8 is huge. Does that make sense?
Yep.
Okay, any questions? All right, other group.
Okay, so we had kind of a similar hypothesis. Wondering the average age of
Your microphone's not working so much.
For the 2019, 2020. I know, I'm on my hotspot. No, should I type it?
I think you're doing just fine.
Yeah, you're doing good now. It's just you were off about 3 or 4 seconds. It was your internet was.
Okay, I'll try my best.
I think
so our H naught was, the mu was 28.9, and the H 1 mu was going to be less than 28.9 for. So for that part, we did of the starting roster of the San Francisco 49ers, and we used the top 5 players whose ages were 37, 33, 32, 32, and 31. The type but it was in fact true. In this case, the age is in fact 28.9, but we said that it would be lower. And for type 2, the null is false, but we failed to reject when in fact the age is lower. For the T, we got 0.999 and a p-value of 3.9.
Wait,
so
3.9? You can't get a p-value of 3.9.
Is the opposite.
Yeah, it could be the opposite.
It is.
Oh, did I write that backwards?
Yeah,
I
p
did.
can never be bigger than 1 because p is a probability, right?
You're right. You're right.
Yeah.
So I wrote those backwards. Okay, hold on. So p-value was 0.999, right? And then the T was 3. Significant evidence to conclude that the population mean of the San Francisco 49ers starting roster is less than 28.9. And then for the p-value, if the population mean age is 28.9, and another study was done, there's a 99% chance that the new study will result in a greater age, or in the, oh my gosh, hold on, in a greater age than 28.9. Did I write that one down wrong? Michelle, what do you have on that?
I already threw away my papers.
Then 33.
Then 33, that's what it was, yes. And that's what we have. Thank you, Anna.
Okay. And is this one of those where it's hopeful and you should increase your sample size because you can make the study happen? Or is this one of those where the standard error is just fine and there's no reason to do another study?
I think we could always do another study and that we could always increase our sample size, but I'm not sure if it's necessary.
What's your p-value? Look at the p-value.
Is too high.
Yes.
Your p-value is as high as it gets, 0.99,
I have a question about that.
which means, yeah, sure.
Like, is there a number? Is there some sort of relationship that can help us decide when it's okay and what's not? Because that's pretty wishy-washy. Like, obviously,
Yeah.
99 not, but at what point is it? At what number?
Sometimes it has to do with how driven you are,
Mm-hmm.
how much effort and resources you've got.
So
So there isn't like a mathematical number for it, but 0.99 is clearly too high.
yeah, no, I understand that.
Let's say at that point is your hypothesis is probably backwards.
I think what happened was when I secured the data, I think there's a chance that it may have been in chronological order. So that did screw up our entire program. And I didn't realize that at the time.
Right.
I only just realized that this second going, why were those all so high? And I think that it was likely in chronological order.
That's possible. And in that case, it's probably a matter of extreme bias. That's what that is. There's no
Okay.
more bias than that. Than
Right?
saying, I'm only going to take the biggest numbers or the smallest numbers. That's the
Right.
most biased you could be. Does that make sense?
Yes.
And it doesn't mean you were evil or anything. It just meant that your sample was as biased as you can get. Do you see that? Because you only took the high numbers,
Yes.
and that's going to be biased, super biased.
And
I
with
didn't even notice that.
just a few moments to work on it, I did not even put it together. I just went, yeah, these are all high. But I didn't put any more thought into it to go, why is it so high?
I think I want to talk about the project. We need to get there. And I'm going to share my screen because that is an important part, and we can't not do it today. Okay, so the first thing is, I think the easiest way is just go to the syllabus. There's lots of ways of getting to the project page. But if you go to the syllabus, I think there's 3 different links that I'll send you to the project. So if you go to project 2, then that'll give you the project 2 requirements. So that's the first thing, is to know where to find stuff. Okay, second is there are some similarities and there's some differences between project 1 and project 2. Let me talk about the most important similarity, and that is this is still a group project. So you must have team members, and you do not have to have the same team members that you had for project 1. Okay, we have lost some students, so you definitely don't assume that if you work together and you had a good time and it was great, that they're all still in the class, that we have lost some students from the class. So make sure that you can get together, and the same rule, it has to be 2 or 3. Okay,
So every time my partners quit,
right, so you need to find new partners.
well,
That's what
definitely.
that means. So
But
find new partners.
it
So
came
maybe in the
down
chat
to the last
box,
minute.
maybe you can put something in the chat box now, see if any of them can get it. There's some others that aren't here today. We have a few more. We haven't lost everyone. It just feels like it. It's just some people don't come. And hopefully they'll get to work. But definitely you can have 2 or 3 in your partnership, and you need to make sure that happens. Okay, so that's the biggest similarity between project 1 and project 2. Okay, project 2's content is totally different than project 1. That's a big note. Don't do project 1 again. Okay, it'll be very bad for you grade-wise. The whole point of project 2 is a hypothesis test and a confidence interval. And obviously that wasn't part of project 1 because we hadn't even gotten there yet, but we're there. Okay, so that's the main thing. It's all about confidence intervals and hypothesis tests. Okay, and second is, and one of the similarities is you're still going to identify a client. Makes it easier for you to write to if you have a client, an audience that you're writing to. Does that make sense? So you should identify that in your project, and let me know. If nobody would be interested in it, then it's not a good project because it's not interesting. So better be interesting to someone. You don't have to truly get paid for it. In fact, you're not going to get paid for this. So that's fictitious, just like project 1. Any questions on that?
Can you assign groups since not everyone's here and so it takes a lot of time to find
Assign
people?
groups, but if you email me, I can see if I connect you with other people. If everyone else has a group, I'll get you in a group. So I'm the instructor, so I could be pushy. So I'll make that happen. But I'm not going to randomly assign groups, but I will make sure you have a group. But I was hoping maybe someone in this group, I don't know whose groups and all that, but maybe you can be with someone who doesn't have 2 other people already they're working with. That's best. Okay. So in terms of what you're going to be doing, another big difference between this project and project one is that this is not about the sampling technique. This is not about trying to get a scientific study. Okay, it's not wrong if you get one, but it's not a requirement of the project. Okay, but you do need to collect data. You also do not have to do a survey. So one of the things that should have helped you is what we did today. And that is you collected data, right? Okay, but you still have to have a data set that's more than 30. Okay, the reason why you got to have such a small one today is we didn't have much time. But for your project, you can have time. And again, you can find data. One of the things about the data that you're going to collect, if you can collect the entire population, it's not a good project. Because if you can get the whole population, there's no reason to do a hypothesis test. You just know 100% for sure. There is no level of significance. You just know. Does that make sense? So ages of the 49ers, that's no good because it's easy to just grab everyone. It's not that, there aren't that many 49ers. When is this due? I think it's June 6th or 7th. I'd have to look. I'm doing it by memory, but it's, I can copy in the syllabus. So you have some time still, a few weeks. But you have a test next week too, so there we go. It is June 9th, so it's even later than I thought. I was remembering wrong. So June 9th is when the project is due. So it gives you time, but again, this is the kind of thing where you don't want to do last minute. You can do, you can grab things online, that's fine. And in the state we're in now, that's probably the easiest is to grab things online. You can do your own experiment, that can work too. But I'm not going to let you do anything that doesn't involve social distancing, because I don't want to get in trouble for that. So make sure if you can do something, it's got to be with social distancing. But again, online is much, much easier. Got it? Okay, so again, the main things you're going to be doing are a confidence interval hypothesis test. I want to show you the spreadsheet. You're used to this page on the spreadsheet. I don't know if you've noticed, but there's a lot of tabs. So for this project, we're in the TÜV-Erstat tab. Okay, whereas in project one, you had one set of data. For project two, you're gonna have two sets of data. And what you're doing is you're gonna do a comparison study. I'm not gonna get into the detail of what a comparison study is all about, because we talk about that on Tuesday. But I just wanted to make sure that on Tuesday, we have enough time to go over the test and review for that. So that's why I thought today would be the right day, even though it's a little early. And then there's the test, and then it becomes a little too close to the project if I just start then. So you're going to be getting, you can do a comparison study, and that could be, say, I don't know, men versus women. It could be last year versus this year. It could be lots of different things that you might want to compare. It could be two answers to the same question that you're surveying, okay? Or two things. So you might want to do, I don't know, something like don't do what I tell you. If I say it, you can't do it. You have to do your own idea. But you could do something, you can go online and you can find out what the temperature of South Lake Tahoe and North Lake Tahoe is. Yeah, over some 50 selected days that you choose from the past. And you can compare those, and that's comparing two different places. Does that make sense? So that's going to be what the big difference between project 1 and 2. One of the big differences of project 2 is going to be a comparison study. Okay, any questions? Okay, then once you, by the way, the first thing you do is you can decide what you want to do for your study. The order in which you do things is the same order that we've been talking about this week. First thing is decide what you want to do. Second is just write down your null and alternative hypotheses. And that's going to be about a comparison of two things, which we'll talk about next week. So the third thing you do after that is talk about the type 1 and type 2 error. And this is going to be the order in which you write it in your paper. Okay. So unlike project 1, project 2 has a very defined order at which you write things. Okay, after you've done the type 1 and type 2 error, then you're going to collect your data. So don't even look at data until you've done that part. Then once you've collected your data, you're going to put it in the spreadsheet. And you must use the spreadsheet. You can't use a calculator. And the reason for that is that there are some universities that require a spreadsheet for transfer. That if you didn't use a spreadsheet, your class doesn't transfer and you will have to retake this class. And I will tell you, my guess is that if I told you this class doesn't transfer to your university, my guess is you'd probably drop right now, am I right? So in my opinion, my number one responsibility is to make sure this class transfers. So this ensures a bunch of universities, because I get calls from them saying, did they use a spreadsheet? And as soon as I say yes, then they check it off their list and they say, yes, it transfers. Okay, I'm not saying every university, but there is a group. I believe UNR is one of them, and that's our closest university. Okay, I know not all of you are going to UNR, but there are some others like that too. So that's just a note. That's the reason why I require the spreadsheet. It's not because I'm being mean. So once you put that in there, it turns out, and again, we're not ready to understand this yet, but it will either be an independent difference or a dependent difference. I'm not going to talk about that now because we won't understand that until Tuesday. Okay, but the project's not due for a while, so that's okay. Once you know which it is, then you're going to go and all the statistics are there for you. By the way, including the standard error. Okay, whichever one you happen to be doing, there's the standard error there. Okay, so, and that'll work. Any questions on that so far? So by Tuesday, here's number one in terms of objectives by Tuesday. Have a partner or two partners. If you only have one partner, please allow someone that wants to come into your partnership. Please say yes, okay? You can't have the same groups if they're still in the class. We have lost some people in the class. Obviously, if they're not in the class, then they're not your partner anymore. I think that should be obvious. The only reason I would say that you can't have the same groups is if there are 3 of you and there's one person left out, then I'm gonna split you up into 2 groups just because I wanna make sure everyone has a partner. Does that make sense? But there's one person that can never make it to these lectures. So I'm hoping that the one person that doesn't have one can maybe partner with that other person. So I'll see what we can do. The person is doing their quizzes and stuff, but emailing me. So they watch it archived. So that's a possibility. Okay, any other questions on this so far? Okay, let's go back to this. Okay, you are going to talk about the sampling technique. It is fine if you say convenient sampling. You just have to say what you used. So like I said, it's different than project 1. You just have to identify your sampling technique. If you say it's convenience, then you talk about the bias, and that's okay to have bias as long as you talk about it. Okay. Any questions about that? Let me go into more. Okay, a list of the summary statistics. An interpretation of each, that is of the combined summary statistics. So again, focus on these guys. Okay. You don't have to do everything like project 1, but you should have the difference between the population means, sample means, because that's kind of the whole point of the project. So that one is important. The standard area you're gonna have to do a whole paragraph on. That'll be the hardest part of the whole project for y'all, for most people. Okay, so that'll be a biggie in terms of the statistics. So again, and if there's anything that just shouts at you, you can add those 2 in, but definitely the mean and the standard error. Those are the kind of biggie for the statistics. Okay. Let me drive this into you. without comments about the standard error throughout the paper, you cannot receive an A. So you got to talk about how the standard error relates to the confidence interval. You got to talk about how the standard error relates to the hypothesis test. And you should talk about the standard error by itself. Okay. Since standard error is so hard, I made a video on the standard error. So I'll let you watch that by yourself, but it's here. You just click that. It's also on YouTube, but you can click it here and it's a little faster to find. And that'll give you, I think it's like an 8-minute video on the standard error or something like that. Okay, you're going to be doing a confidence interval for the difference, and you're going to interpret it. So again, that's last week's stuff. Okay, although it's going to be for the difference between two means. And again, if you go to the spreadsheet, it's all there. See CI lower, CI upper, whether you're doing that one or that one. Okay, it's there for you. The calculation, don't spend time talking about how you calculated it. Okay, you could cite that you use the spreadsheet, but don't go into the formulas because they're not important for the project. Your client doesn't care, got it? But you need to talk about why you chose the confidence level. Here's what you should not do. Don't say, I chose 95% because alpha was 0.05. And don't say I chose alpha as 0.05 because I had a 95% confidence. Okay, those are separate things. Okay, so that's a big deal. They're separate things. The confidence level, you can plug in. Let's say you have one of these guys, you can plug in 0.95. It's very easy to plug it in and look, and then you'll get these guys. You can plug in 0.99, and it gives you different numbers eventually. It should at least. I think our sample size, I don't know what's going on here, but it might be, it just took time. That's what it was. Okay, I think the problem is they're equal here, so these numbers are weird. So you can plug in anything you want. So in other words, experiment and explore your confidence levels, talk about your exploration, talk about the pros and cons of each, and then talk about which one you wanted to decide on. Whereas you don't get to explore the level of significance because that is decided on type 1 and type 2 error before you even look at the data. Any questions on that? Okay, so that's just a note. You should talk about the margin of error. You should talk about the lower bound. You should talk about the upper bound and explain what your client is going to do with all this stuff. For everything you talk about, you should have a sentence on how your client is going to react. Does that make sense? Okay, and very important. I'm going to let you read through each of the paragraphs, but I want to give you some of the emphasis on stuff. Okay, hypothesis test, again, I've kind of talked about that. But again, focus on how your client is going to react to all these things. Don't just give me the definition of the p-value. Based on that, now what is your client going to think? Do you see? How is the client going to use that p-value? How is the client going to use the solution or your conclusion? So it's all about that. It's not just the one sentence. These are paragraphs. Okay. Talk about assumptions. If you had any assumptions you needed. Okay. And the bias is going to be the biggie. Okay. And then again, talk about how everything's important and how your client's going to use this stuff. And then at the very end, you're probably going to talk about, if you had more time, how would you do more studies? So based on the standard error, do you need to do another study? Okay, just for the study that you did. And if you don't, then maybe there's some other questions that are related you might ask. Okay. One thing I did do, I think it's in here. I didn't do it yet. So I have a rubric for you. Talks about, what you're supposed to do. So we're kind of officially out of time, but I'm always happy to answer questions, but I get through the end of the project. And what I recommend you do, if you have discussions, No one has posted on the Project 2 discussion board. It's time. I need a partner is one thing you might want to post. So that's something you can post. Another thing you can post when you do have partners is, this is my idea, will it work? And then I'll help you with it. Anna will also help. Right, Anna? Okay, so we're here for you. I check my email a lot. Even over the weekend, I'll be around a little bit, but I'm going to be hiking a lot. And you have some weeks, but I wanted to kind of get you thinking about it, especially get you think about partners, because that's the one you want to be working on right away, is finding partners.
And guys, remember, if you have any questions, I won't be tutoring Sunday or Monday, but if you need any help today, Tuesday, or Wednesday, I can extend my hours on Wednesday before the exam if you guys need it. Just please let me know.